Good day. So this is lesson 1, Introduction sa Statics of Rigid Bodies. So my apologies dahil na-corrupt yung file. Hindi ko siya ma-present dun sa Google Slides. Ayun lang. So, engineering mechanics is a subfield of applied physics concerned with the mechanical behavior of structures, machinery, and materials. It entails applying physics and mathematics ideas to engineering problems involving static and dynamic forces. Statics is the study of the balance of bodies at rest. It is concerned with interpreting forces operating on structures or objects that are not moving. Engineers utilize statics to determine the forces and moments applied to things, guaranteeing that they are balanced and will not move in any direction. Dynamics is the study of moving bodies. This field of engineering mechanics studies the forces and moments that cause motion as well as the motion itself. It encompasses the study of object acceleration, velocity, and displacement in response to applied forces. So, introduction to statics. Forces. Ano nga ba yung mga forces? So, force is a vector number that describes the interaction of two things that results in a push or pull. It is distinguished by both magnitude and direction. Forces acting at an angle to the coordinate axis can be reduced into manually perpendicular forces known as components. The component of a force parallel to the x-axis is known as the x-component. The component parallel to the y-axis as the y-component. So, characteristics of forces. Magnitude of the force. The direction of the line along which the force acts. It is also known as the line of action of the force. Nature of the force. This is denoted by placing an arrowhead on the line of action of the force. The point at which the force acts on the body. So, the principle of transmissibility. According to the concept of transmissibility, a force's point of application can be shifted anywhere along its line of action without affecting the external reaction forces on a rigid body. Any force with the same magnitude and direction and with the point of application anywhere along the same line of action will induce the same acceleration and moment. As a result, the places of application of forces can be changed along the line of action to simplify rigid body analysis. Types of loads based sa geometry. Point load, uniform or rectangular load, triangular varying load, and trapezoidal load. So, types of loads based naman sa characterizations. Dead loads are permanent or stationary loads which are transferred to structure throughout the lifespan. Live loads are either movable or moving loads without any acceleration or impact. Wind loads are primarily horizontal load caused by the movement of air relative to Earth. Snow loads constitute the vertical loads in the building. So, axioms of mechanics. The parallelogram law. The resultant of two forces is the mean diagonal of the parallelogram formed on the vectors of these two forces. Two forces are in equilibrium only when equal in magnitude, oppositely directed, and collinear in action. Number 3. Any number of sets of equilibrium forces may be added to any force system without changing the external effect of the original system. Number 4. Action and reaction forces are equal but oppositely directed. So, components of planar forces. Components of a force may be resolved either by the use of trigonometric functions or use of slope. When looking at the geometric representation, the components of a force can be perceived as horizontal and vertical changes, or as integers in the algebraic model. Components of a force represent the combined vertical and horizontal forces that combine to make the resultant force. Horizontal component, the part of the force acting along the chosen horizontal axis. Vertical component, the part of the force acting along the chosen vertical axis. So ito yung tinatawag natin na Sokotowa. Ito yung sine theta is equals to opposite over hypotenuse. Yung cosine naman, cosine theta is equals to adjacent over hypotenuse. Ito naman yung tan theta is equals to opposite over adjacent. So, yan nga. Ma-apply natin ito mamaya sa example. So, ito na yung problem number 1. Solve for the x and y components. So, ang gagawin natin, i-observe muna natin yung problem and titingnan natin kung nasan ba yung mga directions niya. So, dito sa problem na to, makikita natin may right angle dyan, which is ito yung fx, yung x-axis natin, at ito yung y-axis natin. So, pag bubuuin lang natin siya, magiging ganito yun. So, dito, i-apply natin yung Sokotowa. So, pag tinignan natin, dito sa problem na to, magagamit natin yung cosine. Yung cosine is equals to adjacent over hypotenuse. So, since nandito siya, ito yung opposite, which is yung fy. So, dito sa right triangle na to, ito yung 18 newtons, ito yung hypotenuse natin. Pag sinabing hypotenuse, yun yung pinakamahabang line. So, itong fx naman, ito naman yung adjacent natin, which is fx. Ito namang fy, ito yung opposite natin. So, para makuha natin yung fx, ang gagawin lang natin is gagamitin natin yung Sokotowa. So, cos 40 is equals to fx over 80 newtons. I-cross multiply lang natin. So, mangyayari fx is equals to 80 cos 40. So, pag kinalcue, maging fx is equal to 61.284 newtons. So, same lang din sa fy, gamitin lang natin sa Sokotowa. Gamitin natin yung sine, which is sine is equals to opposite over hypotenuse. So, ito yung opposite natin. At ang hypotenuse natin ay itong 80 newtons. So, ang gagawin natin, cross-multiply lang. Magiging fy is equals to 80 sine 40. Magiging fy is equals to 51.423 newtons. Tapos, ang gagawin natin dito ay gagamit lang tayo ng Pythagorean theorem. Gamit yung mga nakuha nating values, which is fx equals to 61.284 and yung fy is equals to 51.423. So, ito na. The square root of 61.284 squared plus 51.423 squared is equals to 80.